For billions of years, the sun has generously radiated light, sustaining life on Earth. It can both nurture life and pose a danger. Its rays can warm some while drying others. Despite its proximity to Earth and centuries of observation, the sun remains largely a mystery. It holds many secrets, and studying it presents an incredibly complex challenge. So, what do we truly know about our nearest star? Let's find out. On November 21st, 2021, the Parker Solar Probe approached the Sun at a record distance of just 8.5 million kilometers, becoming the first spacecraft to reach the solar corona, the extremely hot outer layer of the star. Why did we need to get so close to the Sun, overcoming numerous technical difficulties? What exactly is the Parker Solar Probe looking for in such extreme proximity? The Sun is a main sequence star about 4.6 billion years old. Currently, it belongs to the spectral class G2V, making it a typical yellow dwarf. The surface temperature of the Sun is approximately 5,780 Kelvin, around 5,510 degrees Celsius. Although there are both hotter and cooler regions. The inner layers, including the corona, heat up to millions of degrees, but their contribution to the visible part of the radiation is almost negligible. The average diameter of the Sun is about 1.4 million kilometers, making it 109 times larger than Earth, and its mass exceeds the mass of Earth by 333,000 times, accounting for 99.9% of the total mass of the solar system. Although the Sun is considered a small star by galactic standards, it is actually larger and brighter than 80% of all known stars in our galaxy. Hydrogen is the Sun's primary fuel, undergoing nuclear fusion in its core, gradually turning it into helium. These reactions occur at temperatures of about 15 million kelvins, producing an enormous amount of energy. In the core, the temperature reaches colossal values, creating the necessary conditions for such reactions. The core is surrounded by the radiative zone, where heat is transferred by absorbing and re-emitting photons. This zone occupies about 70% of the star's radius, and the light created inside can stay in this region for 10,000 to 170,000 years before reaching the outer layers. Next is the convective zone, where plasma actively circulates, carrying heat upwards. The continuous swirling motions of the substance generate magnetic fields that permeate the entire solar system. Additionally, the upper layers of the Sun, such as the photosphere, emit visible light, which we can observe from Earth. The outer part of the solar atmosphere, the corona, consists of giant bursts of plasma, with temperatures ranging from 1 to 2 million kelvins, and its structure remains largely mysterious. One of the significant scientific questions is how the corona can be much hotter than the lower layers. The Parker Solar Probe was created to study this mystery. The Parker Solar Probe is an automated NASA research station launched in 2018. After a series of maneuvers using Venus's gravity, the probe gradually approached the Sun. Its primary goal is to study magnetic fields near the Sun, measure energy flows, and investigate the solar wind. Despite the extreme conditions, intense temperatures, and radiation, the Parker Solar Probe has already transmitted a wealth of valuable data back to Earth. It is expected that by 2024, the probe will approach the Sun at a distance of just 6.5 million kilometers, reaching speeds of up to 200 kilometers per second. However, the mission of the probe will not be long-term. Eventually, its instruments will fail and it will plunge into the depths of the Sun, where it will be destroyed. Nonetheless, it will collect crucial data that will allow us to better understand the processes occurring in the solar corona and its secrets.